Welcome back. We're going to continue working with fractional exponents. And cranking through some of these ideas, we're going to get into some interesting situations when it comes to these factor trees. So if you have 64 to the 1/2 power, what does that mean to you now that we've learned this a little bit? It means that we're looking for square root, right? Square root of 64. So what it means is we're trying to find things that multiply to give us 64. The first thing I think of is 8 times 8 to give me 64. And since this is a square root, I'm going to be looking for pairs of numbers. I've already found a pair of numbers that work, so the answer is 8. Okay, 8 times 8 is 64, and that means that there's a square root there. All right. Now, we're going to do a few different problems to kind of like draw attention to certain things that I want to make sure you understand. So let's go over here on the right-hand side. What about 8 to the 1/3 power? What does that mean to you now that you understand fractional exponents? It means this is a cubed root, right? So it basically means that I need to figure out and write a factor tree. So in this case, 2 times 4 is 8, but I know that 4 is 2 times 2. So I've got it all done, but this is a cubed root, so I'm not looking for pairs, I'm looking for triplets of numbers, and I found 3 numbers that are identical, so I can pull it out one time. The answer is 2. This makes sense because 2 times 2 times 2 gives me 8. That's what a cubed root is. Okay? So now we want to go and crank up the complexity level just a little bit. And let's take a look at, in this case we did 64 to the 1/2. Let's look at negative 64. But not to the 1/2. Let's look at it to the 1/3 power. Let's see if is there an answer to this. All right, so the way to do it is you need to write that factor tree, but it gets a little bit messy when you have a negative number that you're trying to do a factor tree for. And I'll kind of explain why as we go. There's a couple of different ways to do it. The easiest way to do it is to think what times what times what can give me 64. And if you do some thinking on it, you'll find out that negative 4 times negative 4 times negative 4 does give me negative 64, because negative times negative is positive, but then times another negative means I'm going to get a negative answer. 4 times 4 is 16 times 4 is 64. Okay? So what we end up having here is, on the right-hand side, the answer to this is going to be negative 4. And that's what you're trying to do when you're trying to find a cubed root. You're trying to find out what times itself 3 times is going to give me what I have here, and that works. But you may not think about this right away. You may not know that 4 times 4 times 4, first of all, is 64, and you may not know that you're going to have negatives in every one of those spots. Now, this is the correct answer, but a lot of times when you're doing these factor trees, it's kind of difficult for you to know to put negatives down in here. So even though I showed you that, the way I actually do it is if I'm taking the cubed root